A very pleasant good morning to you all. I welcome you all to the physics online class. Dear students, as per our school management instruction, today onwards we are going to start the online class. Children, just you have to listen the videos and you have to take a notes. Okay, it will be helpful for your higher studies. And today we are going to discuss the important chapters. It will be helpful for your higher studies. Okay, so please you have to utilize this time. Okay, yes, today we are going to discuss lesson 4, electricity. Okay, in this lesson you all know that many units and symbols and formulas are there. Okay, so first we are going to learn the units and the symbols. The electric current SI unit ampere. It can be represented the symbol A. What's the unit of electric current? Ampere. The symbol is A. Second one, the charge, electric charge. The unit is coulomb. What's the unit of electric charge? Coulomb. It can be represented the symbol C. Next one, electric potential or potential difference. It can be represented volt and the symbol is V. Okay, what's the unit of electric potential? Volt. Symbol is V. The unit of the resistance is ohm. The unit of resistance, ohm. It can be represented by the Greek symbol, this ohm. Okay, and electrical resistivity, the symbol is ohm meter. Electrical resistivity is ohm meter. This is the symbol, ohm meter. And the SI unit of the conductance. Okay, resistance opposite only conductance. Okay, the unit is ohm power minus 1 or mho. It can be represented by mho or ohm power minus 1. And the electrical conductivity, the unit is ohm power minus 1 meter power minus 1. Electrical conductivity ohm power minus 1 or meter power minus 1, or also it can be represented mho meter power minus 1. The unit of work done is joule. Okay, what's the unit of work done? Joule. It can be represented by the symbol J. And the electrical power unit is watt. Okay, the unit of electrical power is watt. It can be represented WH. The unit of electrical energy is kilowatt hour. The unit of electrical energy, kilowatt hour. Okay, it's very important one. The unit of electrical energy is kilowatt hour. And now we are going to learn some of the important formulas. Okay, it will be useful for doing sums. So we are going to learn the formulas. First one, electric current. You all know that. What do you mean by current? Yes, rate of flow of charge is called current. Rate of flow of charge. That means charge flowing per second. That is called current. Okay. The charge flows per second is called current. So this current can be represented with simple what? I. Okay. I be the current and it is equal to Q by T. Q means what? Charge divided by time. So current I is equal to charge by time. Current I is equal to charge by time. Here I represent current and Q represent the charge and T represent the time. And what is the unit of this current? Ampere. Okay. The unit of the current is ampere. Now we are going to define what is 1 ampere. See, 1 ampere is equal to 1 coulomb by 1 second. That is, if 1 coulomb of charge flows per 1 second, that is called what? Current. Okay, 1 ampere of current. Okay, the formula for 1 ampere, 1 coulomb by 1 second. Okay. Now from this, suppose if they are asking you to find the charge. Charge is equal to current into time. Okay, Q is equal to I into T. Okay, charge is equal to I into T and I is equal to current is equal to charge by time. Next we are going to discuss that formula, that is potential difference. Okay, you all know that what is electric potential or potential difference? Yes, yeah, amount of work done to move the unit positive charge from one point to another. That is electric potential or potential difference. Okay, amount of work done to move the unit positive charge from infinity to that point means that is electric potential at a point. Here potential difference means to move the unit positive charge from one point to another, that is called electric potential difference. It can be represented V is equal to work done by charge. Okay, work done by charge is equal to potential difference. So V is equal to W by Q. Okay, so work done represented by the symbol W, charge can be represented Q. Okay, so what's the formula for electric potential or potential difference? V is equal to W by Q. Okay, V is equal to W by Q. Here what is W? Work done. Q is equal to charge. Okay, now the potential difference between the 2 points are represented A and B. Okay, suppose we are going to discuss the potential difference between the 2 points A and B. So what's the formula? V is equal to VA minus VB. That means potential difference at a point A minus potential difference at the point B. So here is the condition. If VA is more than VB, that means the potential difference at the point A is higher than at the point B. Okay, so VA minus VB. Okay, now if the potential difference at the point B is high means how will you calculate the potential difference? V is equal to VB minus VA. Okay, the potential difference at the point VB is greater means VB minus VA. Okay, the potential difference at the point B minus the potential difference point A. Okay, now we are going to discuss the formula. What is 1 volt? Okay, 1 volt is equal to 1 joule by 1 coulomb. 1 volt is equal to 1 joule by 1 coulomb. Why it is 1 joule? Yes, work done unit is equal to joule. Okay, charge unit is equal to coulomb. So we can define what is 1 volt if 1 joule of work is done to move the charge of 1 coulomb. Work done is equal to V into Q. What's the formula for work done? Potential difference into charge. Okay, so here we discussed V is equal to W by Q. Okay, what's the formula for potential difference? Work done by charge. And suppose in this problem, potential difference and charge if they are giving, we can calculate the work done. Okay, work done is equal to V into Q. And now we are going to recall the formula for Ohm's law. Okay, we all know that Ohm's law tells the relation between the current and the voltage. Okay, the current and the potential difference. Okay, so according to Ohm's law, what he told that at a constant temperature, the steady current flowing through the conductor is directly proportional to potential difference between the two ends of the conductor. Have you all remember the Ohm's law? Yes. Okay, steady temperature, the constant current flowing through the conductor is directly proportional to the potential difference between the two ends of the conductor. That's why we are writing I proportional to V. Okay, current is directly proportional to the potential difference. Okay, and V is equal to I into R. Okay, potential difference is equal to current into resistance. Okay, so here this R, it is called as the proportionality constant, and it is represented resistance. Okay, voltage is equal to current into resistance. Okay, so from this formula we can find the value of resistance. R is equal to voltage by current. R is equal to V by I. Okay, resistance is equal to V by I, and I is equal to V by R. So current, if you want to find current, means potential difference divided by resistance. Okay, so I is equal to V by R. Okay, so here this three formula, keep in mind. V is equal to I into R, that is the basic formula from Ohm's law. From that we can find the value of resistance and also the value of current. Okay, V is equal to I into R, and R is equal to V by I. Voltage by current gives resistance. Okay, voltage by current give resistance, and current is equal to voltage by resistance. Okay, if you want to find the current I, we can find what the ratio of potential difference and resistance. Okay, if you are finding, we can get the value of current. So here you all know that I represent current, yes. V represents what? Potential difference. Then R represent resistance. Okay, now we are going to discuss what is 1 ohm. 1 ohm is equal to 1 volt by 1 ampere. What is this meaning? If the current is 1 ampere and the developed the potential difference is 1 volt, means the resistance is 1 ohm. Okay, the resistance developed in the conductor is equal to 1 ohm. Okay, 1 ohm is equal to 1 volt by 1 ampere. Okay, you all know that resistance is equal to potential difference by current, V by I. Okay, so how to represent 1 ohm, 1 volt by 1 ampere. Okay, so next one, what is meant by electrical resistivity? Okay, you all know that now what is resistance, isn't it? Unit also we studied. And what is electrical resistivity? So the electrical resistivity is directly proportional to the length of the conductor and inversely proportional to the area of the cross section of a conductor. That means if you know the thickness of the conductor, it is increases, means the resistance value will be decreases. Okay, already we discussed that, isn't it? Okay, so resistance is directly proportional to length. That means length increases means resistance also will be increases. Okay, so and it is inversely proportional to what? Area of the cross section. By combining these two equations are proportional to L by A, length by area. Here this R is equal to rho into L by A. Here this rho is called as the proportionality constant, that is electrical resistivity. That is electrical resistivity. So R is equal to rho L by A. So here rho represents what? Electrical resistivity. So from that we can find the value of electrical resistivity. So electrical resistivity is equal to resistance into area divided by L. Okay, electrical resistivity, what's the formula? R A by L. Here R represents the resistance, A be the area of the cross section and L be the length of the conductor. So resistivity, what is the formula for electrical resistivity? Yes, rho is equal to R A by L. Okay. Please keep in remember resistivity formula R A by L. R represent resistance, A area of the cross section, L be the length of the conductor. Okay, next one is what do you mean by conductance? Okay, conductance is nothing but the reciprocal of resistance. Okay, conductance means reciprocal of resistance. The conductance can be represented as simple G. Okay, so G is equal to 1 by R. Okay, reciprocal of resistance. And now we are discuss the what is conductivity. Okay, now we are going to discuss what is meant by electrical conductivity. The electrical conductivity can be represented as simple sigma. Okay, electrical conductivity can be represented as simple sigma. So sigma is equal to 1 by rho. Okay, the reciprocal of electrical resistivity is called conductivity. So sigma is equal to 1 by rho. So keep remember resistivity is represented as simple rho. Okay, this is the symbol of rho and this is the symbol of sigma. Okay, so conductivity can be represented as simple sigma. And now we are going to discuss the formulas for the system of resistors. Okay, so there is two methods are there. One is series and another one is parallel. You all know that, isn't it? So now if the three resistors are connected in series, what is the formula? Rs is equal to R1 plus R2 plus R3. Okay, three resistors are connected in series connection. How will you find the effective resistance? The effective resistance Rs is equal to R1 plus R2 plus R3. Okay, so three resistors are connected in series. This is the formula. Rs is equal to R1 plus R2 plus R3. Now, if the resistors are connected in parallel, okay, three or more resistors are connected in parallel combination, how will you represent the formula? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, three resistors are connected in parallel. What is the formula? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so three resistors are connected in parallel. The effective resistance is equal to the reciprocal of the effective resistance is equal to the reciprocal of the individual resistance. Sum of the reciprocal of the individual resistance. Okay, so keep this, remember these two formulas. Okay, series means just you have to add R1 plus R2 plus R3. Parallel means 1 by R1 plus 1 by R2 plus 1 by R3. Next one, Joule's law. What's the formula for Joule's law? H is equal to I square into RT. Here the H represents amount of heat. Okay, the amount of heat produced in the circuit, it is equal to amount of heat produced in the resistor is equal to directly proportional to square of the current for the given resistance, and directly proportional to resistance for the given current, and directly proportional to time to which the current flowing in the circuit. Okay, so H is equal to I square or T. Okay, Joule's law formula, keep remember, H is equal to I square or T. H represents amount of heat, I means current, you all know that, R is resistance, and T be the time. Okay, so Joule's law, H is equal to I square or T. Next one is, what is electric power? Okay, so power, electric power, how to define electric power? Yes, rate of doing work is called power. Okay, the rate of doing work is called power. So power is equal to work done by time. Okay, power P is equal to work done by time. Okay, then work done, how will you find the work done? Work done is equal to voltage into current into time. Okay, work done is equal to voltage current into time. So divided by again this time. Okay, so here what will happen? This time, this T and this T will get cancelled. So the remaining value, what is there? Voltage into current. Okay, so these two terms will get cancelled. So power P is equal to voltage into current. So what's the formula for power? Voltage into current. Okay, now we can define what is 1 watt. Okay, 1 watt is equal to 1 volt into 1 ampere. Okay, so if the electric power is said to be 1 volt, if 1 ampere of this current flowing through the circuit and the potential difference is 1 volt, means the electric power is equal to 1 watt. Okay, and the bigger unit and all we can represent kilowatt. Okay, and the electrical energy can be represented kilowatt hour. So what do you mean by 1 kilowatt hour? Yes, 1 kilo means what? 1000 watt. Okay, 1 kilo means 1000 watt. Okay, 1000 watt into hour. So if you are convert this hour into second, okay, 1 hour 60 minutes 60 seconds is there, isn't it? So 1000 into 60 into 60. So if we are calculating, we will get this value 3.6 into 10 to the power 6 joule. Okay, 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Okay, what do you mean by 1 kilowatt hour? Yes, 3.6 into 10 to the power 6 joule. Okay, 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Okay, I hope you are all understand all these one words, I think. Okay, once again shall we recall what we learned? Yes, okay. Unit of electric current, ampere. Charge, coulomb. Electric potential, volt. Unit of resistance is ohm. Unit of electrical resistivity is ohm meter. Unit of conductance is ohm power minus 1. Electrical conductivity is ohm power minus 1 meter power minus 1. Unit of work done is joule. Unit of electric power, watt. The unit of electrical energy is kilowatt hour. And we learned the formula, current I is equal to Q by T. Okay, 1 ampere is equal to 1 coulomb by 1 second. Charge Q is equal to current into time. The unit of potential difference is work done by charge. Okay, and 1 volt is equal to 1 joule by 1 coulomb. Work done is equal to potential difference into charge. And the important relation, Ohm's law, I proportional to V, V is equal to I into R. And electrical resistivity, what's the formula? Yes, our resistance is equal to rho L by A. So rho is equal to R A by L. The conductance G is equal to 1 by R. Conductivity sigma is equal to 1 by rho. Resistors in series, Rs is equal to Rn plus R2 plus R3. In parallel, 1 by Rp is equal to 1 by Rn plus 1 by R2 plus 1 by R3. Joule's law, H is equal to I square into RT. Electric power, what's the formula? Work done by time. So power is equal to voltage into current. And 1 kilowatt hour is equal to 1000 watt hour. Okay, it is also equal to 3.6 into 10 to the power 6 joule. And today's your work, you have to be write down all the one words, okay, units, okay, from the book.